Okay, so I'm going to run through how to load the part into CAD CAM software. So first of all, what we'll do is up the top, we'll go to Tools, down the bottom we'll go to Add-ins, and then we'll look at the bottom for Solid CAM. So I've already got it loaded in, as you can see with the check mark, and then I'll go OK, and then you'll see these toolbars at the top appear. What we'll do then is we'll go into Solid CAM part. We'll go to New, Milling Operation, and then the part will appear. We'll go tick for New Milling Part, and then it will take us to the context menu. And what we can do now is establish our coordinate system as well as our stock size for the part. So for the coordinate system, what we'll do is we'll select on the part that we want. And then as you can see up the top here, we have the Z-axis being our up and down, X-axis and Y-axis being the plane through the part, which is what we want. Cool, so we'll hit tick. Next, coordinate system data, that's all good. Hit next, and then what we'll do is we're going to establish our stock size. So we'll select the CAD part that we want. And as you can see, it makes a very large box around the part. And then what we'll do is we will adjust it accordingly. So what we'll do is, so for the Z axis negative, that's -2, so that's 2 down. I'll just change that to 0. For the Z plus, I'll change that to 1. And then for both the Y values, I'll change that to 0 as well. So change that to 0. And as you can see, it changes the box size around the CAD part. So we have 1 mil clearance at the top, 0 at the bottom, and then 0 on the 2 flat sides as well, and then 1 mil clearance on each of the arcs on the side. Cool. So happy with that. We're going to hit next. We're going to specify our CNC machine. So in this case, we're going to be using the Fonk. This is just because it's very similar to the one that we have in the workshop, as stated by Ahmed during the lecture. And then we're going to hit next, and then it's going to generate all the settings we require in order to create our milling operations. Alright, so now that we've loaded our part in, we can start adding our milling operations. But in order to generate milling operations, we need our tools first. So what we're going to do is we're going to go over here to our little tool section. We're going to right click or double click, and it's going to bring up our tool table. So as you can see, I've already added a few for my operations down here, but I'll just run through on how to add new ones, and then I'll go through the ones that I've added already. Cool. So in order to add a new tool, down the bottom here, you'll see this little plus icon, so add milling tool. We're going to click on that. We're going to get a big list of the different tool types on the side here. And so for basic cutting operations like pocket milling or facing and stuff, we can essentially choose a couple. So for example, if we had a very big part and we just needed to face the top, we would choose the face mill. But because our part is relatively small, we can choose a large end mill. So I'm going to select that, and then we get this big context menu here. So it's relatively straightforward. Everything here relates to all of these abbreviations here. So you can just click on them and it will take you to that little menu. So in this case, I want a 10mm cutting diameter end mill. So what I'm going to do is I'm going to click on the diameter. It's going to take me up here, and I'm going to hit 10, and then I'm going to hit enter or click out of it. And what that's going to do is it's going to adjust the rest of the parameters of the end mill to essentially scale it up to the 10mm from the 6mm. So if I go back and I change it to a 6mm, then I click, see how it's going to change the shoulder diameter, the arbor diameter and everything for me as well, just so it relates back to the 10mm. Cool. So we're going to do that, and then what we're going to also do is we're going to change the shoulder length. So I'm going to change that to be 50, and then we're going to go from there. You're going to hit save. What you can also do is you can change the tool number, so that just changes essentially what the NC code will spit out for tool changes. As well as where it's stored. So if you have a machine with multiple spindle holders, you can choose that. Whereas if you don't and you just have one that chooses one from storage, you can choose that position as well. Can also label the tool. So if you have it and you need it for a specific operation, you can label it after that operation just so it doesn't get lost. And then, yeah, you just hit save, and then it will save the part in your tool library. But what I'm going to do is just going to delete that one. Cool, and then I'm going to go through the ones that we have. So part one for me is pretty much the same tool that we just made. I'm just going to update that because it always seems to change back. I'm going to hit save. Part two is going to be a 6mm diameter end mill. The reason for this is because I have smaller cutting operations within the actual part that require a little bit more detail, and the 10mm was too big to fit. In spindle number 3, we've got a ball nose mill. This is diameter 5mm, a corner radius of 2.5, and this is for the profile cutting operation on the hemisphere that we have. And that essentially allows us to get that nice curve on the sphere. So in spindle number 4, we have a drill. So we do have through holes in our model, and so in order to actually start the hole, we would want to use a drill to essentially create an initial opening for our end mill, and then our end mill can essentially pocket that hole out for us. And then in position 5, we have another end mill that we're going to use for those pocketing operations for the through holes. And as you can see, the end mill is smaller than the drill. If we were to go into that hole with the exact same size end mill, we would run into clearance issues, so I've opted to go with a smaller end mill size. Perfect, so those are all the tools. Now I'll go through the cutting operations. So in operation 1, we have essentially our major operation, and what this is going to do is it's going to rough out probably 80% of the material for the part, just to save us the most amount of time. Otherwise, if we're spending a lot of time cutting with different size tools and changing tools, we're going to lose time doing that. So basically that's what this operation does. It's going to take all the material from the top of the stock all the way down on the outside. Doesn't reflect it here, but there is still a connection there to hold the part to the stock where it's being clamped. But in here as well, it will go in, it's going to do a roughing cut on the pockets, and that's just going to allow us to get as much material out of the part as possible. Cool. So for operation number 2, what we have is we have a pocket milling operation, still using the 10mm tool. It's similar to the first op, but it's basically in this one we're looking at a much smaller overlap. Where is it? Yeah, a much smaller overlap percentage, and a much larger step down. So again, we're just trying to get the material from the inside of the pocket out now. So the first operation got it down to the level. Second operation is going to take from inside the pocket, as well as trying to get material out of the cube features over here. Alright, so for our third operation, it's going to be a facing operation. And basically what we're doing is we're just taking material off the top of these cube features just to get them down to the level that we want. And I believe this one is using the 10 mil as well, using a 50% overlap as well as a 2.5 step down. This is because we want a decent surface finish, and as you can see, the floor offset's also set to 0. So this means we're going right down to the actual surface that we want. So this would be our final sort of surface finish on the cube features. Cool. So for op 3, we're going to be doing the through holes. So as you can see here, they're plunging in and then they're doing a spiral cut out. And this is essentially because we need them to spiral out because they're such a small diameter mill compared to the size of the hole. And so that's just going to jump from hole to hole with the clearance being set to, I believe it's 1 millimeter or 2 millimeter above the working part. Cool. So for the next operation, we're going to have our finishing operation on the inside geometry. And as you can see here, it's mainly used for taking the material out of the cube features here, and that's going to give us a really nice surface finish on the sides as well as the bottom, but it's also used to get the surface finish required on both the edge of the part as well as the floor of the part, because it was still quite high up from before, and I believe the step over and the step down are quite, yeah, so the overlap is 80% as well as the step down being 1. So it's doing a lot of passes. So this is probably the most time consuming step out of them all. It can probably be optimized a little bit more as well on top of that, just to save a little bit of time, because I'm sure there's diminishing returns the more overlaps you do. Alright, so moving on to the next step, we're going to be looking at the operation on our hemisphere. So this is using the ball nose end mill. We're going to go into settings, and as you can see here, if we look at the stock, the way it changes, it's basically just doing that profile on the edge here. And so for this, we're using the ball nose mill in number 3, so diameter of 5 mil. In terms of the clearance level, I've set it to be 1 millimeter above the stock height, so that's from here to here. And then the lower level for this is set to the shoulder, as that's where the cutting stops for the part in reference. So in terms of the technology, alright, so in terms of the overlap, we have it set at 0.6 or 60%, and then our step down is really small, so it's set at 0.4, and as you can see, there's a lot of layers of cutting. So again, this is another really time-consuming process just to get that really nice surface finish on the part, which I'm sure is critical. But it's not specified in the drawing what the surface finish should be. So I've just assumed that this one is going to be quite nice. So I've spent a lot of time milling that. Alright, and then our final operation is essentially just releasing the part from the rest of the stock. So there are still connectors there because it is below the stock below, and basically the operation just faces this to what's required, and then it releases these corners. And then in terms of the clamping for the part, the clamps on the actual mill will be on this face and then on this face as well. So yeah. From here, to generate the actual NC code or the G code for this, basically what we'll do is we'll go right click operations, we can go calculate and G code all, or we could just go G code all and then go into generate. And basically what that's going to do is it's going to generate all the lines of the code for us, as well as the tools, the tool changes, the directions, as well as the move operations. And that's going to go all the way down for the part. And then what we can do is we can go File, Save As, and then it will save it as a text document for us. Perfect.